Hello, everybody. Welcome to this new session on Excel for Finance, where we will talk about future value and present value with multiple compounding. So in session 4, we saw how to compute the effective rate when compounding is done more than once a year, and the formula was effective rate is equal to 1 plus nominal rate divided by m, which is number of times compounding is done in a year, to the power of m minus 1. Now let us see how to compute the future value and present value when compounding is done more than once a year. Let's take an example. See, I want to know what would be the maturity value of a deposit of rupees 50,000 that I make today for a 5-year period in a bank offering 8% interest per annum. Here, the bank is compounding the interest quarterly or 4 times a year. The formula that we studied in the first session of future value, which is equal to present value into 1 plus r to the power of n, is slightly modified here. What we do is future value is equal to present value into 1 plus r divided by m to the power of n into m. And therefore, present value becomes equal to future value divided by 1 plus r by m to the power of n into m. The only difference here is we are dividing the rate of interest by number of times compounding is done in a year, that is m, and multiplying the number of years n by m. This is the only difference we have. Otherwise, our formula that we studied in the first session remains the same. Now let us see how to do this calculation using Excel. Okay, so here I have an Excel spreadsheet where I've taken 2 examples. Let's look at the first example, the same one which I had shown you in my presentation. I am depositing rupees 50,000 today at the rate of 8% for 5 years in a bank deposit where the interest is compounded quarterly. So my amount of deposit, which is present value, is 50,000. Since I'm paying it today, I'm showing it as minus 50,000. Interest rate per annum R is 8%. Number of years for which I'm depositing the amount is 5 years. Frequency of compounding is quarterly. Since quarterly compounding is done, number of times compounding done in a year, which is m, is 4. So before we apply the formula of future value and present value, what we need to do is we need to divide r by m. That is, we have to convert the annual interest rate to interest rate per period or interest rate per quarter. For doing that, I'll just take this 8%, divide it by 4, it becomes 2%. The number of periods is 5 years. Instead of 5 years, now it should become number of quarters. So if it is 5 years, it should be equal to 5 multiplied by 4. That is, we have 20 quarters now, or 20 periods now, not 20 years. Now let us take the formula that we studied in the first session. The formula is same, is equal to future value, bracket open, rate. We are not going to give 8% now. We are going to give this r by m, which is 2%, comma. Number of periods, we are not giving number of years now. We are giving number of quarters, which is 20, comma. We ignore PMT, one more comma, and present value, which is 50,000, the amount of deposit made today. Bracket close, enter. So if I deposit 50,000 today in a bank deposit offering 8% interest compounded quarterly for a 5-year period, at the end of 5 years, I'll be getting 74,297.37. Now let us look at another example where we talk about present value. What is the amount to be invested today in a scheme offering 6% interest in order to receive rupees 1 lakh at the end of 8 years? The interest is compounded semi-annually. So now I'm talking about receiving 1 lakh rupees at the end of 8 years. So 1 lakh is a maturity value of my deposit, which is the future value. Interest rate R is 6%. Number of years is 8 years. Frequency of compounding is semi-annual. Therefore, number of times compounding done in a year, or m, is 2. Now let us continue with the same steps that we did earlier. interest rate should be now converted to not per annum, but for half year. So for that purpose, we will take this 6% and divide it by 2. So this is R by M. Instead of 8 years now, we should look at how many half years are there now. So how many 6 months periods are there now? To do that, we will take number of years 8, multiply it with this 2. So we have 16 periods now. So it's going to be 3% at the rate of 3% for 16 periods. So the formula of present value is whatever we studied earlier. So equal to PV, bracket open. Now the rate I will give is R by M, 3%, comma, number of periods is 16, comma, we ignore this PMT and we give future value, which is 1 lakh, bracket close, enter. So I have to deposit today 62,316.69. It is showing as negative because it's a deposit, negative cash flow. So if I deposit 62,316.69 in a scheme offering 6% interest for 8 years, where the interest is compounded semi-annually, I will be able to withdraw 1 lakh rupees at the end of 8 years. Okay, so here we are. So the Excel function is same as what we saw in the first session, which is F is equal to FV, rate, period, and PV, or PV, rate, period, and FV. But before we apply the function, we have to divide R by M and multiply N by M and use those numbers as rate and period in the function. In other words, what we are doing is we are converting the annual rate to rate per period and the number of years into number of periods. I hope you enjoyed watching this video and understood how to calculate future value and present value when there is multiple compounding in a particular year. Thank you very much for watching.